this video, we are going to solve this problem. The problem is, let T is a linear transformation from R4 to R3 defined by T of x comma y comma z equal to, so it's a 4 variables, so that means it belongs to R4. The codomain is R3, so 3 dimensions x minus y plus z plus t. Second is x plus 2z minus t, x plus y 3z minus 3t. Our aim is, I want to find the image of t and kernel of the t. So how we are going to approach this problem is, we convert the given linear transformation into a matrix representation. Then we apply we know the result, kernel of T is null space of a matrix. Similarly, image of T is column space of the matrix. So first step, I want to find given linear transformation to matrix representation. How I can show there is no basis. So I have assumed that the standard basis only I am going to take. Okay. First step, I want to find at first we find the matrix representation of linear transformation. So what I can, so I want to choose the basis alpha equal to, so it's in R4, so 1 comma 0 comma 0 comma 0 and 0 comma 1 comma 0 comma 0 and 0 comma 0 comma 0 comma 1 and finally 0 comma 0 comma 0 comma 1. This is the basis for domain space. Beta is a basis for codomain space, that is in R3. So 1 comma 0 comma 0 and 0 comma 1 comma 0 and 0 comma 0 comma 1. So this is the basis of alpha for the R4 and the R3 respectively. Then my first aim is, I want to find the linear transformation is, they already given T of x comma y comma z is they given. Now I will find the T of 1 0 0 0 is nothing but, I will get first one is 1 1 1 I will represent. So this is I can taken as, now my frame is, I want to find what is the T of 1 comma 0 comma 0 comma 0 in the coordinate vector I want to require. That meaning is 1 1 1 of beta is nothing but 1 times 1 comma 0 comma 0 plus 1 times 0 comma 1 comma 0 plus 1 times 0 comma 0 comma 1. So the coordinate vector is also same vector only will get. So coordinate vector is, I will get it as this one will come. So the coordinate vector is become, again it is 1 1 1. This is the coordinate vector of, similarly T of 0 comma 1 comma 0 comma 0. The coordinate vector please calculate. So I already calculated from my side. So your coordinate vector is minus 1 0 1 will come. Okay. If you have any doubts in the finding the coordinate vector, we already posted a video how to calculate the coordinate vector. Okay, I will give the link in the description. You can watch it. Okay, The next is T of 0, 0, 1, 0. The coordinate vector is 1, 1, 1, 2, 3. T of 0, 0, 0, 1. The coordinate vector is 1, minus 1, minus 3. This is your coordinate vector. Then I want to represent in terms of the matrix representation, that is T alpha to beta. It's the matrix representation I want to given as such a way that 1, 1, 1, minus 1, 0, 1, 1, 2, 3, 1, minus 1, 3. This is the matrix representation of the given linear transformation. Okay. So, first step I want to find the what is the image of T. Image of T means simply you find the this matrix, correct? The column space of matrix T alpha to beta matrix. How I going to find the column space? We will do by the first step. I want to convert the row echelon form. Then I want to find the what is the pivot position. Then corresponding columns I want to choose it, correct? So first way I take the column space of A. So let I consider this is the matrix of A. So A equal to I taken as 1, 1, 1, minus 1, 0, 1, 1, 2, 3, 1, minus 1, 3. So I am going to use row reduced echelon form using the Jordan method. The first step I want to choose the first pivot position. So I choose the pivot position is this is the my first pivot position 1. Okay. So then my first row as it is 1, minus 1, 1, 1 will come. The second row, so this position I want to make 0. So that is my aim. R2 becomes R2 minus R1. So this guy is become 0. This guy is become 1. This guy become 1. This guy become minus 2. So next this time also I want to make it as 0. That is R3 is R3 minus R1. So what is the will get it is this guy is 0. This guy is 2. This guy is again 3 minus 1 is 2. Here also you will get it as, so here minus 3, please check it. Yes, here is minus 3, so I made the mistake here. This is minus 3. So then this guy is minus 4, I will get it. So this is the my first pivot position. My second pivot position is this one, correct? So second pivot position I will make it as 1, minus 1, 1, 1, 0, 1, 1, minus 2. So now I want to make R3 is R3 minus 2 R2. So this way I want to make it. So 2 minus 2 is 0, 0. Here also I will get it as 0. So only 2 pivot position only, correct? This is the 2 pivot position. So row reduced echelon forming, this guy also I want to make it 0, correct? So that is I can make it as so second row the third row as it is 0, 0, 0. Second row is as it is 1, 1, minus 2. Then my R1 is R1 plus R2. So here 1, 0, 2, minus 1. Okay, so this is the row reduced echelon form. So clearly my pivot person is, this one is the my pivot person, this one is the my pivot person. So what is the column space mean? They are corresponding original column. So this is the column C1, C2 are the basis of the column space. So basis of the column space equal to 1, 1, 1. That is my C1, correct? My C1 is 1, 1, 1. Then my C2 is minus 1, 0, 1. This is the my column space. But the question is find the image of T. So image of T is nothing but span of the column space, correct? The span of 1, 1, 1 and minus 1, 0, 1. The same frequency. This is the my image of T. So my first problem is we can find it, correct? The first problem is we completed. So this basis means this is the basis of the, these two are the basis of the image of T. My next aim is I want to find the kernel of T. Kernel of T means we have to find the null space of given that matrix, correct? So null space means this is you consider as a matrix U. This is you consider as the matrix U. We already know that n of A equal to n of U. We already studied. So using this result, what is the n of U? I want to find. So n of U means the U times x equal to 0. I want to find the what are the solutions of these equations, correct? The here U is, so I will write U times x equal to 1, 0, 0. This guy is 0, 1, 0. This guy is 2, 1, 0, minus 1, minus 2, 0. This is our U, correct? Times I want to multiply by x1, x2, x3, x4. Or the given problem is they given the directly x, y, z and t. So you have to find it. This is equal to U equal to 0, 0, 0. So then the equation is x1 plus 2 x3 minus x4 equal to 0. The second equation is x2 plus x3 minus 2 x4 equal to 0. So clearly, so these two guys are the only my pivot tensors. So then x1 and x3 are the basic variables. So x1 and x2 are the basic variables. The basic variables are and the free variables are non-pivot positions. So then mean x3 and x4 are, so this guy are the free variables. Free variables x3, x4. So now I am going to solve this one. You will get it as x2 equal to minus x3 plus 2 x4, correct? and so x1 equal to minus 2 times x3 plus x4. So I want to represent in terms of the equation. So x1 equal to minus 2 times x3 plus x4, x2 equal to minus x3 plus 2 x4, x3 equal to x3, x4 equal to x4. So I will write in the vector form x1, x2, x3, x4 equal to, you commonly taken x3 and x4, I will take it. So x3 coefficient I can take as minus 2, minus 1, 1, 0 plus x4 is 1, 2, 0, 1. So these two are the bases of null space. These two vectors are the basis of vector space, null space. So thus basis of n of A is minus 2, minus 1, 1, 0, 1, 2, 0, 1. This is the null space of A, or my question is the kernel of T. The basis of kernel of T is minus 2, minus 1, 1, 0, 1, 2, 0, 1. So this is the basis of null space. I hope this video we solved this problem, how to find the linear transformation, their image of T and their kernel of T. Thank you for watching this video.